But 8.4, the rational zero theorem, kind of brings that all together. We don't always have a polynomial where one of those factoring methods works. And so in order for us to solve it, we have to be able to factor it in some way. And so that's what the rational zero theorem says. This is not the actual rational zero theorem. This is just how you do it. But what basically the rational zero theorem says is that if you can use synthetic division to find one factor of your polynomial, then you can use the remaining part of the polynomial to factor and solve. And so that's what we're going to look at today. So students will be able to factor and determine the zeros. Zeros is another word for solutions of polynomials using the rational. This should be zero theorem. Let me get my white out. Make that perfect. Rational zero theorem. Zero means solutions. And the rational, this should be a Z. It's one of those Mondays, but it's not a Monday. How to use it. So the first thing we're going to do is we're going to list the factors of the constant. So we're going to look at that last term in our polynomial, the one that does not have a letter, and we're going to list out all of those factors. We're going to use synthetic division along with those factors to see if we can find one of them that works. Remember, one's going to work if you get a remainder of 0. Once we find one that works, we're going to factor the remaining polynomial, we're going to split it, and we're going to solve. So this can be something where you might have to use the rational zero theorem once. This could be something where you might have to use the rational zero theorem twice and maybe 3 times. I mean, that is something that we just don't know. So let's jump into it and just kind of see if that helps us understand a little better what we're doing. And so we'll call this example 1. Solve f of x equals x cubed plus 2x squared minus 19x minus 20. So I need somebody to unmute for a second and be brave. I'm looking for one word. At a glance, when you look at this question, if you were to solve it, what factoring method does your gut say we should use?
Grouping.
Grouping. Yes, very good. Good. I got a couple people who said that. Grouping, because we have 1, 2, 3, 4. And this is kind of what I was getting at. When we learn things at the beginning, we're making sure that everything is nice and easy, it all fits, we're getting the routine down, we're learning the method, but everything we know is not always nice and easy and not always fitting. So I'm going to just throw this up here, don't copy this down, but here's that same question. If I used grouping, I would group here, group there. Right here, I would take an x squared out, which would give me x plus 2. The fact that this is negative, I would take a negative 1 out, which would give me 19x plus 20. This is a grouping fail. In order for grouping to happen, this guy and this guy have to be the same, and there's absolutely no way for me to make those the same. So grouping is not going to work. If you had a trinomial where making the x did not work, you could use the rational zero theorem. If you have a grouping part where it doesn't work, you can use the rational zero theorem. So that's what we're going to do today. So the first thing it says to do when using the rational zero theorem is to list the factors of the constant. So I'm just going to kind of do that down here. The factors of negative 20 because this is negative 20 down here. And I'll just give you this first one. They would be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. Factors means numbers that go into it evenly. Those are all of the numbers that go into 20 evenly. Good. So now we're going to start with one of those, and we'll start with the first one. And we're going to make kind of a modified synthetic division table. We don't want to have to write the table out every time. So I'm just going to kind of draw myself a couple lines here and some lines that way. And I'm going to list the coefficients up here. So this is in front of x to the third, we have a 1. In front of x squared, we have a 2. In front of x, we have a negative 19. And then we have a negative 20. So you got to be a rock star with synthetic division for this to work. So I'm going to start with the first one, which is 1. And I'm just going to put a 1 right here this time. So in synthetic division, what did I do with this first term?
Brought it down.
So I'm just going to bring that 1 down. And then I'm going to say, now you're going to have to follow my pen and hear my voice. Look at what I'm pointing at. 1 times 1 is 1, plus the 2 is 3. One times 3 is 3, plus the negative 19 is negative 16. 1 times negative 16 is negative 16, plus the negative 20 is negative 36. This was my remainder. I did not get a 0. If I did not get a 0, that means 1 is not a factor of this polynomial. And so I move on to the next one. The next one is 2. So I'm going to put a 2 right here. And notice how I'm just using a modified synthetic division table. So just like Paul said before, this first term is 1. All of these I'm ignoring now. I'm not using these. If you want to draw a line through them, you can. This first one is a 1. I'm dropping it down. 2 times 1 is 2. Plus the 2 up here is 4. 2 times 4 is 8. Plus the negative 19 is negative 11. 2 times negative 11 is negative 2. Negative 22 plus negative 20 is negative 42. This is my remainder. It is not 0. So that means 2 is not a factor of this polynomial. And I go to the next one. So we did 1, we did 2. Now I'm going to 4. The first term up here is a 1. I'm going to drop it down. 4 times 1 is 4. Plus 2 is 6. 4 times 6 is 24. 24 plus negative 19 is 5. 4 times 5 is 20. 20 plus negative 20 is 0. And there we have it. So we found our first factor using the rational zero theorem and synthetic division. So now I have to take that information and solve. So I know that x to the third plus 2x squared minus 19x. I'm going to write that down here again. So we had x to the third plus 2x squared minus 19x minus 20. This was f of x. I know that that is exactly the same as, okay, I got a 4 here. How do I write that 4 right here? Does anybody remember? Think from our last unit. This is your A, okay? These are your A's. So if one of my A's is 4, it's x minus A, so that would be x minus 4. That's from this one, the one that worked. X minus 4. And then the remaining part, here's my remainder of 0. So this is my constant. This is my x. This is my x squared. So I have x squared plus 6x plus 5. Now I'm going to try to factor this down more. Okay, let's go back to a vocabulary term from 8.1. If this cannot factor more, it's called irreducible. If it's irreducible, then you're going to be identifying your A, B, C. Lots of terminology in here of trying to figure out when you use what. So this is a standard trinomial. I'm going to do this in red. I'm going to go to this side and I'm going to make my x. Okay, so this in front of the x squared is a 1. This is a 5. 1 times 5 is 5. This is A times C, remember. And then my B is 6. This is my B. What's a factor pair that multiplies to make 5 but adds to make 6? 5 and 1. Very good. 3 of y'all said it. 5 and 1. So this is now going to be x minus 4 times x plus 5 times x plus 1. Okay, I want to reiterate, please make sure you're listening and looking, that when you get the 5 and the 1 here and you write them down, you're not done. You have to divide by A every time to check it. So if I go back up here, A is a 1. So if I divide 5 by 1, I just get 5 again. If I divide 1 by 1, I just get 1 again. So in this one, it doesn't matter, but it may matter in other questions. This is a linear, this is a linear, this is a linear. If you remember in 8.1, we said linears mean stop. So this is as far as we can go. This right here is exactly the same as this right here. It's just factored. So what do I do to these 3 binomials now to solve?
Equal to 0.
Equal to 0. Very good. So x minus 4 equals 0. X plus 5 equals 0. X plus 1 equals 0. trying to lift this up. It won't let me. Let me see if I can do this a little bit. Let me kind of slide that underneath there a little bit. There we go. Bring the negative 4 over. X equals 4 is one of my solutions, one of my zeros. Bring the 5 over. X equals negative 5 is another solution. Bring the 1 over. X equals negative 1 is my third solution. So if the question said, what are the zeros, what are the solutions, these would be your answers. If the question says, what is the factored form, so I'll just kind of write that for practice. If it says, what is the factored form, this is the factored form right before you split it. It would be x minus 4, x plus 5, x plus 1. And it does not matter which order these are in, as long as you have the proper binomials there. If the directions asked for both, then you would write this for the factored form and these three numbers for the solutions, also called zeros, also called roots. That's going back to Algebra 1 as well when we talked about quadratics. And that's how the rational zero theorem works, like that. So let's try another one and see what we get. Maybe if I can pick that up. Ooh, it's hard to see. It's blurry. There we go. Let's call this example 2. Solve. Let's call this h of x equals x to the 4th minus 4x to the 3rd minus 7x squared plus 22x plus 24. Too many terms for grouping, too many terms for making the x, too many terms for sum of cubes, difference of cubes, difference. None of those are going to work. So the only way we're going to be able to factor this down and solve it is using the rational zero theorem. So I'm going to start with the factors of 24, which is my constant in the back here. So we know 1 goes into 24. 1 goes into every number. What's the next number that goes into 24? 2 plus or minus 2. What's the next number? 3. What's the next number?
6.
1 before that.
4.
4 times 6, yeah. 4, then 6. So 4 times 6 is 24. 6 times 4 is 24. 8 times 3 is 24. And 12 times 2 is 24. And 24 times 1 is 24, isn't it? So we have a lot of factors here. We're going to use the rational zero theorem to try to find a factor. So I'm going to start by making my little modified table here. My modified synthetic division table. And I'm going to take the coefficients of this up here, and I'm going to write them along the top. So 1 for the x to the 4th, negative 4 for the x to the third, negative 7 for the x squared, 22 for the x, 24 for the constant. And I'm going to start with the first number 1. I'm going to go a smidge quicker, not very fast, but a smidge quicker. The first number drops down, so we get a 1. Keep in mind this 1 comes from the top, not from there. 1 times 1 is 1. 1 plus negative 4 is negative 3. 1 times negative 3 is negative 3. Negative 3 plus negative 7 is negative 10. 1 times negative 10 is negative 10. Negative 10 plus 22 is 12. 1 times 12 is 12. 12 plus 24 is 36. So if you want to put a little x, this one will not work because I did not get a 0 remainder. And I go to the next one, 2. Dropping my 1 down. 2 times 1 is 2. 2 plus negative 4 is negative 2. 2 times negative 2 is negative 4. Negative 4 plus negative 7 is negative 11. 2 times negative 11 is negative 22. Negative 22 plus 22 is 0. Unfortunately, that 0 is not here, though, so we got to keep going. 2 times 0 is 0. 0 plus 24 is 24. So 2 is no good. And then I go to the next one, 3. Scoot that up a little bit. Drop the 1 down. 3 times 1 is 3. 3 plus negative 4 is negative 1. 3 times negative 1 is negative 3. Negative 3 plus negative 7 is negative 10. 3 times negative 10 is negative 30. Negative 30 plus 22 is 8. 3 times negative 8 is negative 24. Negative 4 plus 24 is 0. Check, check. We just found our first factor. So I want you to keep in mind this was h of x right here. This is now h of x right now. We know that 3 is going to work, and we know that it's x minus a, so that's x minus 3. And this is my remainder right here. This is your remainder. So this would be my constant, my x squared, and my x cubed. So now I have x cubed minus x squared minus 10x minus 8. Which, if I look at 1, 2, 3, 4, what method does it look like we want to use here?
Grouping.
Grouping. Okay, now listen to this next part carefully. If grouping worked, you could do that. But grouping does not work on this one. I can just tell looking at it because I don't have any coefficients here, and then all of a sudden I got a 10 and an 8. So now we got to do the rational zero theorem again with these numbers. So now I'm going to scoot down a little bit. Yes?
Could there ever be more than one A that would work for it or no?
No. Well, there kind of technically will. We're about to get another A, but it's an A for this polynomial now instead of the original polynomial. So, but yeah, you'll only get one off the top.
All right.
One each round, I guess I could say. All right, so now I'm going to do the factors. What am I going to do the factors of? What number now?
-8.
Negative 8. Very good. Factors of negative 8. Plus or minus 1 goes into 8. Plus or minus 2 goes into 8. Plus or minus 4 goes into 8. Plus or minus 8 goes into 8. So I'm going to scoot up to there. And I'm going to, again, make my little synthetic division table. But this time I'm using this polynomial because we already know x minus 3 is one of them. So this is a positive 1, a negative 1, a negative 10, and a negative 8. So positive 1, negative 1, negative 10, negative 8. And I'm going to start with my first factor, which is 1 right here. So drop this 1 down. 1 times 1 is 1. 1 plus negative 1 is 0. 1 times 0 is 0. 0 plus negative 10 is negative 10. 1 times negative 10 is negative 10. Negative 10 plus negative 8 is negative 18. So this one's no good. And I go to the next factor. So we did 1, we're going to try 2 now. Drop the 1 down. 2 times 1 is 2. 2 plus negative 1 is positive 1. 2 times 1 is 2. 2 plus negative 10 is negative 8. 2 times negative 8 is 16. Negative 16 plus negative 8 is negative 24. So that one does not work. And I go to the third one, 4. 1. Dropped it down from there. 4 times 1 is 4. 4 plus negative 1 is 3. 4 times 3 is 12. 12 plus negative 10 is 2. 4 times 2 is 8. 8 plus negative 8 is 0. And that is what we wanted. There is our remainder of 0. It seems like it's the third one every time, but that is not always the case. So please be careful. And then we have to write it carefully. Let me go back to the beginning and let me show you something. This was h of x when we started. It had 1, 2, 3, 4, 5 terms. This is still h of x after our first round of synthetic division.
Mr. Scott?
Yes, ma'am.
Pardon the interruption. Do you have Jonathan Babiak?
I do.
Can you send him for dismissal, please?
On his way.
Thank you.
Thank you. Let me finish this one real quick, Jonathan. This is after the first round, I have the x minus 3. So now when I go to the third round, I'm going to leave that right there where you can see it just barely. H of x still has the x minus 3 from above. Now just added an x minus 4 from here. And then from what's remaining in the synthetic division, we get x squared plus 3x plus 2. And if I had to do synthetic division again, I would on this one. But here, for this one, because it's a trinomial, the x actually works. So a times c, 1 times 2 is 2, and then 3. So 1 times 2 is 2, 1 plus 2 is 3. So now I get h of x equals x minus 3, x minus 4, 1 and 2, x plus 1, x plus 2. And this is the factored form. And if I solved it, I would split all of these, as Gilbert said before, x minus 3 equals 0, x minus 4 equals 0, x plus 1 equals 0, x plus 2 equals 0, and I would end up with x equals 3, x equals 4, x equals negative 1, and x equals negative 2. So right here, we used the x method. If you wanted to do the synthetic division again, you could, just so y'all know. I mean, the synthetic division works all the time, but clearly it's faster for me to use this when I can, and so you just kind of have to be aware of that. All right, I'm going to let y'all try one on your own. So we'll call this last one example 3, if I can find a good one. Right here. Okay, here we go. The volume of a box with dimensions x, x minus 2, and x minus 3, I'm sorry, x plus 3, is 56 inches cubed. What are the dimensions? And I'm going to leave you a hint to start with. Volume equals length times width times height. If you are watching this at home, pause the video and try this question, and unpause it when you have your answer. Okay, so if I fill in the volume, which is 56, and the length, which is x, the width, which is x minus 2, and the height, which is x plus 3, I distributed this x into here, and then I FOILed these two binomials to get x cubed plus x squared minus 6x. Now, we've been saying since the beginning of time, in order for me to solve, I have to bring everything over and set it equal to 0, so I brought the 56 over and set it equal to 0. I want to reiterate a really important fact. If grouping would work right here, you should always do it. Those are much faster methods. Grouping does not work, so I'm going to use the rational zero theorem. So I'm going to say the factors of negative 56, I'll put that in parentheses, from right here. 1 goes into 56, 2 goes into 56, 3 does not, 4 goes into 56, 5 does not, 6 does not, 7, I believe 7 times 8, right? 7 times 8 would work. 9 does not, 10 does not, 11 does not, 12 does not, 13 does not, 14 does. So 4 times 14, 2 times 28, and 1 times 56. So those are all of my factors of 56. I'm going to make my synthetic division table here. And I honestly have no clue, but I'm going to guess it's going to be the third one because that's been our luck every time. But if I go back up to my polynomial right here, I have in front of x cubed, I have a 1. In front of x squared, a 1, a negative 6, and a negative 56. So 1, 1, negative 6, negative 56. And I'll start with the first one, positive 1. And I had a great question. If the positives don't work, do you go to the negatives? Yes. Start with the positives, though. It almost always works. So I'm going to bring this 1 down. 1 times 1 is 1, plus the 1 is 2. 1 times 2 is 2, plus the negative 6 is negative 4. 1 times negative 4 is negative 4, plus negative 56 is negative 60. Go to 2. Bring the 1 down. 2 times 1 is 2. 2 plus 1 is 3. 2 times 3 is 6. 6 plus negative 6 is 0. 2 times 0 is 0. 0 plus negative 56 is negative 56. Did 1, did 2, now I'm going to try 4. Bring the 1 down. 4 times 1 is 4, plus the 1 is 5. 4 times 5 is 20, plus negative 6 is 14. 4 times 14 is 56. Plus the negative 56 is 0. And that is what we wanted, that remainder of 0. So that means that we know right here, this is what my polynomial used to look like. Now it's 0 equals, I got the 4, x minus 4. And then from here, x squared minus 5x plus 14. Plus 5. Thank you. Thank you. Thank you. Thank you. Plus 5x. Great call out. So this is a trinomial, and to be honest with you, it says that we're solving, so we're trying to find. It's not asking for the factored form. I would go to the side and probably try my little x. 1 times 14 is 14. And then positive 5. And there is no way to get 14 and 5. I know it seems like 7 and 2, but 7 plus 2 is 9. And if I say 7 and negative 2, 7 times negative 2 is negative 14. So none of this actually works, which means for me to solve this part, I'm going to have to use the quadratic formula. So I'm just going to kind of do that real quick. I'm going to scan down here. So this one's super easy. X minus 4 equals 0. Bring the negative 4 over. X equals 4. And then for this one, my A, B, C is 1, 5, and 14. Which would be negative b, which is negative 5, plus or minus the square root of b squared minus 4ac all over 2a. Which would be negative 5 plus or minus the square root 25 minus 14, 20, 50, 25 minus 56. This is negative 31 over 2. I think so. 14, 28, 56.
Yeah, it's
Yeah.
31.
Okay.
Negative 31.
And so because we have a negative right here, we know that we're not going to get any real solutions. What kind of solutions are we going to get? Okay, and let's talk about that real quick. This is where the intelligent, I mean, we're at the end of the year of our junior year of math. I mean, I know some of us are sophomores, but it's a junior level math course. It's not a generic question saying what are the solutions. This is a question about dimensions of a box. If you're measuring the dimensions of a box, what kind of numbers do you have to have? Real positive numbers. So this right here is my reminder that I don't got to do anything anymore. This is the only number that matters, is that x equals 4. And then I'm going to take that and I'm going to translate that. I know that my length was x. I know that my width was x minus 2. And I know that my height was x plus 3. And that's from all the way back up here. Length was x, width x minus 2, height was x plus 3. So now that I know that x is 4, I know that my length is 4. I know that my width is 4 minus 2. What's 4 minus 2? 2. And I know that my height is 4 plus 3, which is how much? 7. And I can check that by multiplying. 4 times 2 is 8. 8 times 7 is 56. And did it say our original volume was 56? And so I have everything in there as well. So that is the Rational Zero Theorem and how to use it.